So you are welcome to today's class. Okay, you don't have to be scared of all this. I only do this down because of time. Okay, and I'm going to explain everything here in an easy peasy way. Trust me. So today we'll basically be talking about the metabolism of the phenylalanine. So the first thing is what is phenylalanine? Phenylalanine is one of the world's essential amino acid. What do I mean by essential amino acid? It means that what this type of amino acid cannot be synthesized by our body. It means that what you need to take in this amino acid through your diet. Okay, so when you're taking this amino acid can then be used to synthesize other types of amino acid like tyrosine, and it can also be used in other form of proteins. I hope you understand that. So, fine. So, trust me, you are not cramming anything here. So, I'm going to explain this in a way that you don't end up cramming anything. You just must understand it. But for you to understand that, I need to introduce you to some structures, okay, which you might not be familiar with. And one of the structures I will introduce you to is the structure of phenylalanine, the structure of homogentisic acid, and the structure of fumarate, that is fumaric acid and malic acid. Just these four structures, okay? We are good to go. So, but I don't think you should have problem with the structure of phenylalanine because I've done that in one of our video about the structures of the 20 amino acid. If you have problem with that, you can always check our videos on that, on how to do the structure of phenylalanine. Now let us look at this. The phenylalanine, it is just what? An alanine. This is the structure of what? Alanine. Okay? It is just what? Alanine and what? And phenyl. Phenyl group. That's why we call it what? Phenylalanine. So, this is the structure of phenylalanine. But mind you, this is alanine here, but this carbon is supposed to have how many bonds? 4 bonds. But now it is having 1, 2, and 3 from hydrogen, making 5. It means that what? We need to remove 1 hydrogen from here. I hope it is clear. So this is what? The structure of our phenylalanine. So, but what is our aim in this reaction? Our aim is to what? To break down this ring, this phenyl ring, because you don't expect okay, one thing is that you're looking at this ring is a very stable ring, okay, and you don't just expect your body to like take in this ring. So our aim is to what? To break down this ring. But how do we break down this ring? Look at this rubber. Let's assume this rubber is the ring, this rubber band is the ring. So we're looking at this rubber band. It is what? A very stable structure. So for me to make this rubber band reactive, because before you can break this guy, you need to make it reactive. Okay, so for me to make this rubber band reactive, I need to what? Apply some force on the rubber band. You can see the way I'm applying what? Force on the what? On the rubber band. I need to disturb the rubber band. Do you understand it? I need to what? To disturb this rubber band. That is to tell you that, you notice I applied a particular force here, I applied another force here. That is to tell you that what? On this ring, somewhere in this reaction, probably like as we are moving through this reaction, there will be a time that I have to add something here and add something here. That is a force pulling this ring, pulling this ring, so that the ring will be what? Reactive. So the moment this ring is reactive, it will be easy for us to what? To break the ring. Do you understand it? Because the more you stretch your rubber, the easier it gets to what? To break the ring. The more you work, the easier it gets to break the ring. I hope it is clear. So this is the structure of our what? Our phenylalanine. And one thing about this reaction is that what? The beautiful thing about this reaction is that what? Everything that we'll be doing, we will only be what? Adding oxygen. We are not adding any other thing. The only thing we are adding is just what? Oxygen from A to Z. I hope it is clear. So, and mind you, we said we are going to add something here, we are going to add something here. But you don't expect me to just add everything at once. We do everything what? One step after the what? Other. Do you understand that? And also, this guy, this ammonia, You understand your transamination reaction? That is to tell you that what somewhere in this reaction, this ammonia will be what lost, and it will be replaced with what oxygen during transamination reaction. Don't forget that. Also, this one will also be what lost. It will be replaced with what oxygen. Do you understand it? So everything we'll be doing here in this reaction is just what adding oxygen. So the next structure I would like to introduce you to is the structure of a compound called the homogentisic acid. So how do we get the structure of homogentisic acid? Now, the first thing that should come to you, okay, let me write the name. We have this guy called homogentisic acid. So the first thing that should come to your mind is that, okay, how do I draw the structure? Just take this gel. Take it as Gen Z. Okay, take this as what? Gen Z. That is this generation. That is the Z generation, the Gen Z. So when you look at Gen Z, how do you think they dress? This guy, when you see these guys, you see them with what? You see these guys with bottles. You see this guy with bottle. And what do you think they have inside this bottle? Water. That is to tell you that what? In the structure of the Gen Z, we should have something probably like H2O or hydroxy, that is OH. The next thing you see this guy with is that what? You see these Gen Z guys, you see them with ring. You see them with ring. That is to tell you that what? In this structure, we also have what? Benzene ring in this structure. What else do you see these guys with? You see them with what? With chain. But not just an ordinary chain. The chain do have probably like either a very flat pendant. A flat pendant or a circular pendant. Like this. This is the pendant and this is the rope holding the chain. This is what I'm trying to say. You're sorry about that. So this is the pendant of the chain. So this pendant and the rope holding the pendant. So that's to tell us that what? Gen Z, we do see them with ring. Okay. So that is the what? Benzene ring. What else do you see them with? You see them with what? Bottle. And from the bottle, you can take your OH. What else do you see them with? You see them with what? With chain. And the chain, we have the what? A flat pendant or a circular what? Pendant, which is what? COOH. But the question is, how do you think I know that what the pendant is COOH? From the name, IC. IC is telling us that what this thing is what? An acid. It's just the same when you say ethanoic acid. Ethanoic. IC is telling that what? Okay, it is what? An acid. And when we talk about acid in an organic compound, we are basically talking about the what? Carboxylic acid group. Don't forget. And now, this is the pendant, right? But don't forget that what this pendant we need the what? A rope, which is going to hold the pendant. And the rope is the what? CH2. I hope it is clear. I hope it is clear. So all this is for the structure of the what? Gen Z, not the homogen Z. So this is just for the what? Gen Z. So from this back, we have homo here. You can take your OH here. That is, we have another OH here. So this total structure is now the structure of what? Homogentisic acid. Do you understand it? So let us bring all those structures together. Ring, okay. We have a ring here. What else? OH from the bottom. We have an OH here. What other thing? Dependence and the rope holding dependence. CH2, the rope holding dependence, and dependence OOH. Do you understand it? And the last thing is this OH. Okay, and you know where this one is coming from? From this homo. I hope it is clear. The structure is clear. But as an engineering guy, you don't have to stress yourself. Just take this whole structure as what? Homo Gen Z. You know what homo means, guys? Homo means child. Okay, and that is the Gen Z child. So now let's move on. Now, what other structure do we need to know? The structure of what? Our fumaric and malic. Okay? But now, the first thing I will talk about was fumaric. Let me say this. So for the fumaric, we have something called fumaric and malic. That's this IC is telling you that what these two guys are what? Acid. Fumaric acid and malic acid. Okay? These two guys are what? Isomers. They are what? Isomers. And they are what? Geometric isomer. Meaning that what? They are what? Cis and trans isomers. Hope it is clear. But how do you know that what? How do you know which one is the cis, which one is the trans? Cis and trans. So now, looking at this fumaric, just take the name of the fumaric. It starts with F, right? Fumaric starts with what? F. Turn this F upside down. When you turn the F upside down, you are going to get what? A T. That is to tell you that what? Fumaric is the what? The trans isomer. As simple as that. Automatically, the malic will be the what? Cis isomer. Why fumaric is the what? Trans isomer. Even from the name, fumaric and malic. Okay, fumaric and malic are what? Isomers. Hope it is clear. Fumaric, malic, isomers. These two guys are isomers. But how many carbon do you think each of them have? They have 4 carbon each. This help will also tell you that what? Okay, these guys have what? 4 carbon each. This fumant, we can also take that as fuel. Okay? Meaning that what? They can cause fuel. That is to tell you that what? They have a double bond. Do you understand? They can cause fuel, meaning that what? They have a double bond. IC is telling you that what? They are what? Acidic. Okay, I will take all that again. Fumaric. Ma is for the what? Malic acid. Okay. I is telling you that what? Fumaric and malic are what? Isomers. Hope that is clear. The next thing is that what? Ordinary F will tell you that what? They have what? 4 carbons. Okay. FUM will tell you that the FUM is what? Fume, right? Which you can complete it as what? Fume. Meaning that what? They have a double bond. Double bond causes fume, right? What other thing? I see here is telling that what? They are acidic. Hope it is clear. So it means that I can draw the structure, right? And you know which one is cis and which one is trans? Fumaric is the word trans because you can change the F into what? C. So that is the trans. I hope it is clear. So they have 4 carbon. Okay. They are acidic. OOH. But they are what? They are acidic. That is, you have OOH here at the back too. 1, 2, 3, 4 carbons. Acidic here and here. Acidic. Fume. Because they cause fume, they are going to have what? A double bond in the middle. Not here, it will be what? Here. This is the middle because we have 1, 2, we have 1, 2. I hope it is clear. I hope it is clear. So, the next thing is for us to balance the bond. We have hydrogen here, 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 we have hydrogen here. Okay, we have hydrogen here, we have hydrogen here. Do you think we are supposed to have hydrogen here? No. Hydrogen should not be here because of the double bond. A normal carbon should have how many bonds around it? 4 bonds. So this is 1, 2, 3, 4 for this carbon. So it is complete. So this is either a what? A fumaric or malic. And between fumaric and malic, which one do you think it is what? The most stable? Fumaric is what? I mean, between trans and cis, which one do you think is stable? Cis is what? A stable isomer. Why? I'm sorry. Trans is a what? A stable isomer. Why cis is not what? Stable. Trans is what? Stable. Why cis is not stable. And do you know why I say that? Because in trans, I will not do that, okay? I will just show you this. In trans, if this is the guy, in trans, a force will be pulling from here, or something is pulling from here, and something, another compound is here. One compound is here, one compound is here. It's just as if, do you understand now? Someone is pulling me from here, another person is pulling me from here. Someone is pulling me, yes, someone is pulling me here. What do you think I'll be? I'll be stable, right? I'm not moving. I'll just be stable like this. But when we talk about cis, if this is the guy, one is pulling from here, the other one is pulling from here. What do you think will happen to the guy? The guy will just be going up. The guy will not be stable. His leg might even be shaking. Do you understand? So that's why you see that what trans. So that's that about the cis and the trans. So don't forget, the fumaric is the what? Is the trans, and it is the what? The stable one. Why the what? The malic acid is the what? The cis, and it is the what? Unstable one. So that is to tell you that during the course of this what reaction, it will get to a point where we are going to get this the malic and the what and the fumaric. That's to tell you that what we are going to get the what the malic first, then the fumaric. Why? Because the malic will just serve as an what? Intermediate. Why the fumaric will be the what? The main product. That is the malic, then the what? Fumaric acid. I hope that is clear. So don't forget, so just a quick recap. The fumaric, okay, acid. From the fumaric, we can get fumaric and what? Malic. The two guys are what? Isomer. Fu plus fumaric plus malic are what? Isomers. Also, fumaric plus malic, they are what? IC. And IC is for what? Carboxylic acid. Ethanoic. Homogentic. IC is telling you that what? They are what? Acidic. Also, the F of what? Fumaric can be converted to what? T. Which the T means what? It can either be what? A trans. The T is telling you that what? It's trans. Or the T can also tell you that what? Okay, it is 2 IC. That is, it has 2 carboxylic what? Carbon. Okay. The F can also tell you that what? The F itself can also is also telling us that what? It is what? 4 carbon. That is, the fumaric is what? 4 carbon. So if the fumaric is 4 carbon, the malic will also be how many carbon? 4 carbon. And you understand it because they are what? Isomers. So that is that about that. Also, from this fumaric, we can also take the what? FUM, which is what? Fum, which can be converted to what? Fume. And when we talk about fume, we are talking about the what? The double bond. Okay, that is to tell you that what? In the structure, it will also have a what? A double bond. I hope that is clear. And this is how we draw the what? The fumaric or the what? Malic acid. Okay. 4 carbon. 1, 2, 3, 4. 2 carboxylic acid. This 2 IC. Carboxylic acid here. Carboxylic acid here. The fume, double bond. The double bond here. I hope it is very clear. So this can either be a what? Fumaric or malic. So I'm not doing the isomers for you, probably like how they look like. I think I'll say something about that. So now, okay, now, but I have something I need to say here. Now, this is what? It is having an what? This carboxylic acid here, right? But if I should take this hydrogen and oxygen from here, this will be what? Converted from what? Acidic to what? Carbonyl compound. So this will not be a what? A carbonyl compound. I hope it is clear. So it was having, it can lose this hydrogen and oxygen here too. So it means that what we have 2 carbonyl compound at the front and at the back too. But initially, it was having IC because of the what? Carboxylic acid group that was there before. Now, the carboxylic acid group has been removed. It now has what? A carbonyl what? Compound. It means that what? The name will change from what? Fumaric to what? Fumaril. YL. You know, the same thing for what? Malay. So don't forget that your pyruvic acid is the what? The simplest compound that has what? The carbonyl carbon and a carboxylic what? Carbon. So the pyruvic is the what? The compound, the simplest compound that has what? This and this together. So it means that in the structure of a pyruvic acid, I'm gonna have this O H, okay? So it has this and this. So being the simplest, it means that what I will just add a CH3 to it. Okay. So this is the structure of our what? Pyruvic acid. This is the structure of our what? Pyruvic acid. So adding an H to it and removing this carbon, we turn this to what? Lactate or lactic acid. Okay. But this is what? Pyruvic acid. Okay. Removing the double bond and adding a hydrogen to this, rather, we turn this to what? Lactic acid. I hope it is clear, but I don't need lactic acid here. Just know that what you can get your lactic from pyruvic. Okay. So this is it. So this is the pyruvic acid. So mind you, if this hydrogen is not there, okay, it means that what? Instead of pyruvic, it will be what? Pyruvate, but they are still almost the same thing, sure? Okay, now let's move into the reaction. So don't forget, I said that in this reaction, our aim is to what? To break down this what? This ring. Our aim is to break the what? The ring. And how do we break the ring? We must disturb the ring. We need to what? Disturb the ring. It means that what? I need to add something here and add something here. And what are the things I'm adding? I'm adding oxygen here and I'm also adding what? Oxygen here. And don't forget, I said this side also, we are going to remove this ammonia and replace it with oxygen. This COO minus also, we're going to remove it and replace it with what? Oxygen. But we are not just going to add everything at once. Everything is what? One step after the other. Okay? It is one step after the other. Can I continue? So it means that, so now this is how we are going to do it. The first thing we are going to do, you notice that what? We have two things to do. The first thing is to what? Add something here, add something here. To remove this, replace it with oxygen, remove this, replace it with oxygen. That is what for. So this is how I'm going to do it. I'm going to add one thing here first. After that, I'll add one thing here. Okay. Now the next thing is that what? I will add to both of them at once. The first guy, this, add one oxygen here. The next thing is what? Remove this ammonia and add oxygen. The next thing is then what? Add oxygen to this and add oxygen to what? To this at the same time. So now let us go. Now this oxygen, we have two molecules of, you have two molecules of oxygen, or should two atoms of oxygen rather. So we have one here and one here. So this guy is coming here. Okay. This one of the oxygen will what? Come here. Sorry about that. So don't let me put it there. Let me put it somewhere else. Okay. So I have this O2 here. So one of the oxygen will come here. And why did I choose here? Because in the structure of, because this is going to give us what? Thyroxine. And in the structure of our what? Thyroxine, the OH should be facing this what? This alanine part. They should be facing each other. Okay. So one of the oxygen will what? Come here. This is the oxygen. It will come here and it will be like this here. Okay. Do you notice that? So we have the OH here. Now, the remaining oxygen here will react with what? This BH4. Because this reaction requires a particular what? Enzyme known as phenylalanine hydroxylase. You notice that what? An hydroxyl group has been added here. That is why we call it what? Phenylalanine hydroxylase, an enzyme that adds an hydroxyl or that forms an hydroxyl in the what? In the phenylalanine. That's why we call it what? The phenylalanine hydroxylase. But this enzyme cannot just work alone. It needs a cofactor, which is what? BH4. And we call this BH4 what? Tetrahydro. This is what? BH4. The 4 is what? Tetrahydrobiopterin. I hope it is clear. So it needs this what? Cofactor. So the remaining oxygen will react with the what? The cofactor. And that oxygen is going to take what? 2 hydrogen from the cofactor. So this is going to take 2 hydrogen from the cofactor. And it will form H2O. This oxygen is going to take what? 2 hydrogen from the cofactor and it's going to form what? H2O. It means that what? Here, we will be left with what? BH2, which will be what? BH2. BH4 has now been converted to what? BH2. It will now be what? Dihydrobiopterin. I hope that is clear. So we have our thyroxine here, which is now having our OH. Now, we've added one oxygen to the structure of our what? Benzene, to the structure of this phenyl ring, okay? So the next thing for us to do is to what? To add the oxygen to this alanine side, okay? But how do I add oxygen to it? This is going to undergo a particular type of reaction known as what? Transamination reaction. What is transamination reaction? Transfer of amino or the ammonia part of the what? Of an amino acid. I hope it is clear. So this guy is gonna react to the what? With a compound known as what? Alpha ketoglutarate. From the name alpha ketoglutarate, it means that what? It has a ketone group. And don't forget that what? Our carbonyl compound, we have two types of carbonyl compound. The one for aldehyde and the one for what? Ketone. Okay? Both of them have this CO. Okay? I hope it is clear. Both of them, both carbonyl, I mean the ketone and the aldehyde, they both have this carbon carrying what? Oxygen on it. So what is going to happen here is that this ammonia part will be transferred to this ketone carbon, while the oxygen on the ketone carbon will be transferred to this position. I hope it is clear. And that is how we have this. The oxygen and this double bond, they are going to come here, O and the double bond, while this ammonia part is going to the what? To this carbon of the what? Of the ketone. I hope that is clear. And the enzyme that is involved, the enzyme that will be involved is known as what? Since it is a transamination reaction, so the enzyme will be called what? Amino transferase. But what type of amino transferase? Thyroxine, because this is thyroxine. So we're gonna call the enzyme what? Thyroxine amino transferase. That is why we call it what? TAT. And it also requires a coenzyme which is known as what? PLP. If you understand your transamination very well, this should not be a problem, because in transamination reaction, we have this PLP, which is what? Pyridoxal phosphate. Okay, so this is thyroxine reacting with the what? Alpha ketoglutarate to give us what? This compound in which the oxygen, the ammonia part has been replaced with what? Oxygen. I hope it is clear. So when you look at this guy, if you look at this guy very well, you will notice that what? This is what? A pyruvic, or should I call it a pyruvate? Okay, because of this ion. So pyruvic acid is the what? The smallest compound with what? Carboxylic and carbonyl, right? So this is the carboxylic, this is the carbonyl, and this is the CH2. On and on, it is supposed to be CH3, but because a bond is already coming from here, so we have to release it back to what? CH2. So this is the what? The pyruvic or the pyruvate part. Okay. So how do we name this guy? We have an OH here, and don't forget that what? In the structure of a benzene, we do have what we call the what? The P, the O, and the M. Okay, so this guy is in the P position, this is the P, this is the M, and this is the O position. Okay, so this is the O, this is the P rather. So how do I name this guy? I will call this guy what? P what? Hydroxyl, because the hydroxyl is on the P what position of the ring. So we call this what? P hydroxyl what? P hydroxyl phenyl, because it is on the phenyl. P hydroxyl phenyl what? Pyruvate. Now I think you understand why I call it pyruvate and not pyruvic acid, because the H is not there, right? So this is called what? P hydroxyl phenyl pyruvate. I hope it is clear. Now don't forget, we've added one oxygen here, we've added oxygen here. So the next thing is to what? Add oxygen to what? To the two guys at once. So we are coming here. So this compound, this is it here. Hydroxyl is on the P position, so this is P hydroxyl phenyl pyruvate. Okay, now we're gonna add oxygen to the two sides now, to both this alanine part and this ring part. So the oxygen here is coming here, and it will what? It will attach to this carbon and knock out this COO. Okay, it is going to what? Knock it out. Do you understand that? So it's gonna knock this guy out. This guy will go out, and this guy will go in form of what? CO2. You can see C and 2O. O. So we are going to have what? CO2 what? being knocked out here. And one oxygen, don't forget, it is only one oxygen that is coming. And the one oxygen will replace this COO minus here. Okay. So don't forget. So the remaining one oxygen here is coming here. Do you understand that? Do you understand that? So that is how we have it here. You know, we have an OH here already. So this is the OH. The new OH that is being formed here, this is it. Now, this oxygen has knocked out this COO as what? CO2. So we have the what? This oxygen then attached here. So this is the oxygen now. I hope it is very clear. Now, when you look at this guy, you'll notice that what now we have two guys what disturbing the ring. So I have to what rearrange these guys so that what the OH we have to what face each other. Initially, when we add just a single OH, it has to what face the alanine. Okay, but now when we have two OH, the other OH will not have to face the alanine anymore. It has to face the other what OH because they are what family. Do you understand that? So that was why I said what? Just rearrangement of the what? Of OH. Rearrangement of OH. Okay? So I have this and this here. Okay? Still the same thing, right? I did not change anything. The only thing I did was to what? Put this OH that was here before. I have to like place it here. Do you understand? So I think this will be easier to what to break now because we have something that is what disturbing the ring. Something is pulling it here, something is pulling it here. Okay, and don't forget what structure is this. This is the structure of our what homogentic acid. Don't forget, I said the homogentic acid is going to have the rope holding the chain and the chain, which is what COOH. But this is COO minus. The minus is telling you that what it is not the acid as the hydrogen part has been what given off. So it is still the same thing. Okay. So instead of calling it homogentic acid, it will just be what homogenticate. Okay, I hope that is clear. So this is the homogentic acid now. So I have OH pulling this ring here. I have another OH pulling this ring here. So it can now it will not be easy for us to what to break the ring. I hope that is clear. So it will be easy for us to break the ring. So this is this. Okay. So this thing is they still have the same name. So I just have to call it homogentic acid. But what is the name of enzyme involved? Homogenticate, or you call it homogentic acid. Okay, now look at this guy here. Which enzyme is involved in converting the what? The p-hydroxyphenylpyruvate into the homogenticate. We call it what? P-hydroxyphenylpyruvate dioxygenase. P, that is, this is what I would say. P-hydroxyphenylpyruvate dioxygenase. Why did I say dioxygenase? Because what? The two oxygens are being used on the what? On the same structure. Okay, so I used one here, I used one here. But here I did not call this one dioxygenase because only one oxygen was used here on the what? On the structure. But here, the two oxygens were being used on the what? On the structures. Okay, here and here. So that is how we call it what? P-hydroxyphenylpyruvate dioxygenase. I hope it is clear. I hope it is clear. So now, so this is this homogenticate. This is it here. This is it here. OH, right? CH2, the chain, the rope that is holding the chain, or should I say the chain itself, and the pendant, which is the one at the top here. I hope that is clear. I hope it is clear. This guy here is the same thing as what? COO minus, or I can just write it like this: COO minus. Okay, it is still the same thing. Okay, I hope that is clear. So what are we doing now? To break the ring. Okay, so we need to what? React with what? Oxygen again. So I'm gonna take this oxygen, okay, and I will use the oxygen to break the ring now because I have something stretching the ring now. So what am I doing here? So these two, the whole oxygen is going to come here and it will break this ring here. Do you understand? The oxygen is going to come here and it will what? Break the ring here. So I'm gonna have something like this here. the ring has been what? Broken. Okay? It's just like, let's assume I have a rubber band now. So if I should light the rubber band with my lighter, what do you think will happen? The rubber is going to what? The rubber will be broken, and you will see fire on what? On both sides of the what? Of the rubber band. I hope that is clear. So we use oxygen to break this down. That is to tell you that in each end, you are going to see the fire burning here and the fire burning here. I hope it is clear. I think I have to do it for it to be clearer. For it to be clearer. Is this place showing? Let me check. Yeah, sorry about that. So we have something like this. Okay, now imagine after breaking these parts, okay, we're gonna have something like this. Okay, it has been broken. So you have one of the oxygen here and one of the oxygen here. So the ring has been broken. So we can just stretch the ring now. Okay, so let's stretch the ring. So what is the name of the enzyme required here? The enzyme is just what? Homogentisate dioxygenase. That is an enzyme that adds two oxygen to what? Homogentisate, or that adds two enzymes to homogentisate acid. I hope that is clear. So, okay. Let us spread the chain now. So from the top, we have carbon, O minus is still the same thing. Okay. The next thing is CH2, right? The next thing is what? C. A carbon is here, right? We have a carbon here. The carbon is having double bond and this oxygen, okay? Double bond, oxygen. We are not going to go here, so we are coming this way. We have another carbon, double bond, carbon. That is carbon, double bond, carbon. Carbon, double bond, carbon. Hydrogen. Both of them have hydrogen. Okay, so the next thing is this what? This carbon, double bond, carbon and hydrogen. Carbon, double bond. Carbon. Okay. Hydrogen. But mind you, I think there is, okay, let's just continue. Why this last one? Carbon, double bond. Carbon, double bond oxygen, okay? Double bond oxygen and OH. Okay, but let's look at this thing again. COO, C, double bond, O minus. So this is it. CH2, carbon, this carbon here, double bond oxygen, carbon, double bond oxygen, okay? Carbon, double bond, carbon, double bond, carbon. But this one is having H, this one is having OH. So this one is supposed to be OH, okay? The next thing is carbon, double bond, carbon, okay? So carbon, double bond, carbon, double bond, carbon. Both are having H, okay? So the next thing is carbon, double bond oxygen, carbon, double bond oxygen, and it is also having the what? The OH. I hope it is very clear now. Now, mind you, looking at this guy, this oxygen here is having an hydrogen beside it. So I just want the what? Oxygen to what? Always what? Stay alone. Okay? Apart from this one that is here already. So this one, we have to like do something called tautomerism. Okay? So what is tautomerism? The hydrogen here, we have to come here, and one double bond will replace the hydrogen. Okay? That is tautomerism. So we have, since we are not using, okay. Yeah, I think I should just bring this in. Sorry. Since we are not using this for now, so let me just bring this in. Sorry. So we're gonna withdraw that here. We have carbon. This is a carboxylic. This is carboxylic, right? Just like COO, but the H is not there, okay, but it's still the same thing, okay? Carbon, CH2, then carbon double bond O, carbon hydrogen, double bond carbon OH, carbon double bond carbon H, H, carbon double bond O, OH. So how many carbon do we have here? 1, 2, 3, 4, 5, 6, 7, 8. How many carbon do we have in this compound? 1, 1, 2, 3, 4, 5, 6, 7, 8. I hope that is clear. So I said I'm gonna do tautomerism here because we just broke the we just finished breaking down the rings. So you don't expect everything to just stay like this. So they are going to rearrange, which is why tautomerism is going to what happen here between this double bond and this. So hydrogen is going to come here, and the double bond, one of the double bond will come here. So we are going to have carbon, oxygen, O minus, CH2, carbon, oxygen, carbon, hydrogen. Now, an hydrogen has come here, a hydrogen has come here, rather. Single bond now, okay? Carbon. We have this red bond coming here, and at the bond that was there before, and the what? Oxygen. I hope it is clear. Carbon, hydrogen, carbon, hydrogen. This one is having a double bond, okay? Carbon, OH. Now let us name this guy. Let us name this guy. What do we call this guy? Let us name the guy. So I'm going to divide this guy into what? Into three. Anywhere I see the word oxygen, apart from this carboxylic, okay, this is a group, okay, this is a group also. So anywhere I see oxygen, I'm going to separate them there. So this is carboxylic, they are together. So I will count this one as 1, 2, 3, 4. I can see an oxygen here standing alone here. So I'm going to split here. Also, let me go again. 1, 2. I can see an oxygen here standing alone here. So I'm going to split here. So this is how I'm going to name. Okay, let's look at this guy. COOH, Abi now, carbon, carbon, carbon. This is 4 carbon, 1, 2, 3, 4. It has the carboxylic acid here, okay? But here, it does not have a carboxylic acid. It has the what? A carbonate compound. And don't forget, this can either be what? Fumaril or malate. Had it been, we have another OH here, it would have been what? Fumaric or malate. But now we are only having a carbonate compound here, and it has 1, 2, 3, 4 carbon with a double bond. So that is to tell us that what this guy can either be what? Fumaril or malate. Okay? So, but what are we going to call this thing? A malate, because this will just be the what? Intermediate. Okay? So I'm going to call it what? Malate. We are doing the naming, okay? This is the what? Malate. So what is this? CH. What is this compound? CH3 COOH. This is what? Ethanoic acid. Okay, which can also be called what? Acetic acid. Either you call it what? Ethanoic acid, or you call it what? The acetic acid. So if this guy is not there anymore, if the OH is not there anymore, what are you going to call it? I'm going to call it what? Acetyl. Okay, acetyl. The IC was there because it has OH. Now that the OH is gone, you call it what? Acetyl. So now look at this guy. We have CH2 and C of the what? Of the carbonate compound. On the number, this one is CH3, but this one is CH2. And you understand why this one is CH2, because it has a bond here already. So it is still as if it is still CH3. So we have CH2 and this C carrying a carbonate compound. And it is just so we still call this guy what? Acetyl. Okay? Or you call it acetyl. Acetyl or acetol, they are still what? Both are still the same thing. But because it's at the middle, so I can call it what? Acetol, okay, or acetyl. So acetyl. I will call it acetyl. And what about this one? CH2, which is what? Look at it. CH3 COOH. This is what? Ethanoic acid, or you call it what? Acetic acid. Ethanoic or acetic acid. Okay. But now look at this guy. But if this hydrogen is not there, instead of being IC, it will be what? ATE. Okay. Acetate. Okay. It will not be acetate. Now look at this guy. We have CH2, carbon, OO, and O and O. So that is to tell you that what this is just two carbon, which can either be what? Ethanoic or ethanoate. Okay. Ethanoate or ethanoic, or you can also call it what? Acetic or acetate. So this is what? Acetate. 1, 2, and the what? The carboxyl functional group. So we call this what? Acetate. So that would be what? Mallyl acetyl acetate. Let's do that again. 1, 2, 3, 4 carbon, which is telling us that what? And so what are we going to call it? We are going to call it what? Mallyl, because this is just the what? Intermediate what part. I hope it is clear. So this is the what? From here to here is the what? Mallyl. So this and this 2 carbon with a carbonyl group. Had it been it had O, another OH, we would have called it what? Acetic acid, right? But this guy does not have OH, so it has ordinary O on the carbon. So that is why we call it what? Acetyl instead of acetic. Now, what about this one? So we should have also called this guy acetic. I mean this part acetic, that is acetic. But because the hydrogen is not there, so we have to call it what? Acetate. 8, that is ATE8, that is the hydrogen has been what? Eaten. Okay, so it has what? Undergo ionization. It has given out its what? Hydrogen. So don't forget this mallyl acetyl acetate, but the correct name to give this one is what? Mallyl aceto. Please call your acetyl aceto, because that is how it is being named. Okay, but the acetyl is still aceto, like from the structure they have the same structure, they are still the same thing. So just call it aceto, probably like it is being called aceto because it is found somewhere in the middle, maybe. So we have mallyl aceto acetate, and I hope you understand that. So now this is the what? This is the cis isomers. Okay, because of this mallyl. So this has to be what? It has to be what? Converted to the what? To the trans, which is the stable one. So this is just an intermediate. So this will then be converted. This will then be converted into the what? Fumaril. Fumaril aceto acetate. Now, what do you think will be involved in this what? In this reaction? The enzyme that will be involved is just what? Mallyl aceto acetate isomerase. Just it is just the what? Mallyl aceto acetate isomerase. Okay, so the enzyme here is what? Mallyl aceto acetate isomerase. That is an enzyme that converts mallyl acetoacetate to its what? Other what? Isomers. Isomerase. I hope that is clear. Now, the last thing here is to what? To react this guy with what? Water. And don't forget, this fumaril. If this fumaril should get something, it will be converted to what? Fumaric. Don't forget, if the fumaril here should get something, it will be converted to what? Fumaric. YL to what? IC. Don't forget that what? This YL. Why is it YL? Because it is having what? Carbon and oxygen on it. That means that is to tell us that what? If I should give this guy what? OH. If I should add OH to this guy, it will be converted from this what? Fumaric. That is, if I should add, it has what? CO like this. So if I should add OH to it, it will be converted from what? Being ordinary fumaril, being YL, to what? IC. I hope that is clear. So I'm gonna bring water in here. So I will then react this guy with water, that is H2O. This guy will react with water plus H2O. This is our product to react with water. Don't forget about our water can be broken down into what? Hydrogen ion and what? Hydroxyl ion. Okay. Now, this hydroxyl ion will then come to this what fumarate part from the structure. That is, it will come to this side. You know, this is 1, 2, 3, 4. Don't forget we separated everything here. So 1, 2, 3, 4. The OH, this OH will come here. Okay, that is, it will be added to this fumarate part. OH. It will now be what? Fumaric. Okay, because we have our what? Our stuff here. So it will then be separated into what? Fumaric. I don't think I have to draw that. Just draw the structure one. So the fumaric, so this part, this fumaric here, we have it as carbon, oxygen, OH, the guy that was just added now. We have carbon, hydrogen, double bond, carbon, hydrogen, carbon, double bond, oxygen, and OH. 1, 2, 3, 4. Okay. 2 acidic parts, double bond, right? So we call this guy what? Fumaric. So this is our fumaric. I hope it is clear. I hope it is clear. So it has been converted from what? Carbonyl, just ordinary O, to what? Fumaric, IC, that is acidic. That is the carboxylic, by adding what? OH to it. Now, the next one is what? This remaining part. The hydrogen will then be added to the remaining parts. So where can I put it? Where can I put that? So this hydrogen will be added to what? To this acetoacetate. Where? Now, if I should remove this part, now you know this part is not there anymore. This part is not there anymore. It's because I don't have this. I don't have much space here. So this part is not there anymore. This is all we have here now. Okay, this is what we have here. So this remaining hydrogen here, we just have to come here and it will be what? Attached to this place, just to complete everything. Okay, the fumaric part has been removed, so we just have to like add the remaining hydrogen of water to this side, just for everything to be what? Balanced. And this is still what? Acetoacetate. Okay, 1, 2 carbonyl. This is what? Acetyl, which you can take as your what? Aceto. 1, 2 double bond oxygen and another oxygen, which is what? Acetate. Acetoacetate. So that is that about that. So now let us talk about the clinical correlates. Okay, so but I will not start from this phenylalanine. Okay, I will have to start from this second enzyme here. You know, this is the first enzyme, the PAH, that is phenylalanine hydroxylase, an enzyme that converts phenylalanine to what? Thyroxine. Okay, but I will not start from this enzyme. I will start from this second enzyme, which is what? Thyroxine amino transferase in the presence of what? PLP, that is the cofactor. PLP means what? Pyridoxal phosphate. So I'm going to start from this guy and talk about this guy. Now, this enzyme here is the what? Second enzyme. Why this enzyme here is the what? The third enzyme. Which one is the first enzyme? PAH is the first enzyme, right? Second, third. So now, the second enzyme, the absence of what? This second enzyme will lead to what? Thyroxinemia 2. Thyroxinemia 2. Just use your logic, because this is the what? Second enzyme. So just call it what? Thyroxinemia 2. Second enzyme. Now, for the third enzyme, we have what? Thyroxinemia what? 3. This is the third enzyme, right? So we have the what? Thyroxinemia 3. That is, if in the absence of this what? Third enzyme, or deficiency of the what? Third enzyme, we have the what? Thyroxinemia 3. Thyroxinemia I. So what does this thyroxinemia 2 affect? Your 2 eyes. Okay, your 2 eyeballs. So no problem. So what does this thyroxinemia 2 affect? Your 2 eyeball. Okay, so this is 2. So just take your 2 eye. Okay, we call another name for this is what? Oculocutaneous thyroxinemia. That is, instead of calling it what? Thyroxinemia 2, thyroxinemia. Instead of calling it thyroxinemia 2, you can call it what? Oculocutaneous thyroxinemia. Okay, and it affects what? Your 2 eye and what? Cutaneous, meaning your what? Your skin. Okay. Now, what about this thyroxinemia 3? Now, what does this one mainly affect? From this I, we can actually form something high I. This I can be converted to what letter N? That is I, okay, I and I. That is tell us that what this thyroxinemia 3 what affects the what? The nervous system, which is what the central nervous system. And I hope that is clear. Now, the next one I will talk about is the what? Homogeneity. Now, you will notice that I have to bring this homogeneity, I have to bring it down here so that it's going to react with what? Oxygen in the presence of what? Homogeneous dioxygenase. So, in the absence of homogeneous dioxygenase, this homogeneous acid will not be broken down. Do you understand that? So if this guy is not broken down, it will then undergo a particular type of reaction known as what? Non-enzymatic oxidation. Okay, which will convert it to what? Benzoquinone acetate. Benzoquinone acetate is one of the what? Monomer of a particular type of what? Melanin. Yeah. And this is what we call the what? The what? The blackening of what? Of your what? Connective tissues. Okay. And this will also lead to what? The blackening of your what? Of the valves in your heart. Because the blood is being what? Transferred to the heart. So the benzoquinone that is present in the heart will also what? Get there. So it will cause the what? The darkening of these what? Of these valves. Okay. And apart from that, what this will also cause is it will also cause the what? The tanning of these connective tissues, which will lead to what? Ochronosis. Okay. Now the last thing here is to talk about our last product. Don't forget that our mallyl acetate. Our mallyl acetate is converted to fumaryl acetoacetate, and from fumaryl acetoacetate we have our fumaric and our acetoacetate, right? The enzyme involved here is what? Mallyl acetoacetate isomerase. Mallyl acetoacetate isomerase. The one involved here is what? Fumaryl acetoacetate hydroxylase, because water was added here, right? H2O. Okay. Now, that is to tell us that what? In this last place also, we are going to have what? Thyroxinemia what? 1. We are going to have thyroxinemia 1 if we don't have this what? Enzyme that is going to what? Separate fumaryl acetoacetate into what? Fumaric acid and what? Acetoacetate. So we are going to have what? Thyroxinemia 1 here. Number 2, the enzyme 2, we have what? Thyroxinemia 2. The third enzyme, thyroxinemia what? Thyroxinemia 3. Why the fourth one, which is where we have this homogeneity, we have the what? The acaptonuria. We have the acaptonuria, which is what? Darkening of what? Of our what? Connective tissues, and the what? It is also this benzoquinone that will turn our what? Our urine into what? Dark color. That is the dark color you see in your what? In your urine, and this one is known as the what? Acaptonuria. Now, and this last one is what? Thyroxinemia what? 1. And another name for the thyroxinemia 1 for this, in the absence of this enzyme, another name for it causes what? Thyroxinemia 1. Thyroxinemia 1. And another name for the thyroxinemia 1 is what? Hepato. You have one what is it called? One liver, and the name for the liver is what? Hepato. So hepatorenal thyroxinemia. So how do you know that what? Thyroxinemia 1 is for what? Hepatorenal. Hepato, from the word hepato. Hepato means your what? Your liver. And you know you have what? Just one liver. So hepato, that is the what? Thyroxinemia 1. And it affects the what? The liver, and the what? Renal, which is your kidney. Don't forget about that too. So that is that about that. Why the last one we have to talk So in the absence of what of PA, phenylalanine hydroxylase, this guy is going to undergo a reaction known as what transamination reaction. That is transfer of this ammonia part. So the ammonia will be what transferred out, and it will be replaced with what that oxygen from the alpha keto glutarate. I hope that is clear. So I will just remove this ammonia part and add the what oxygen. In the absence of this what PA, right? This guy here will undergo what this phenylalanine will undergo what transamination, and this ammonia will be what removed and replaced with what oxygen. Do you understand? So this is now what is this? One, two, three. This is your pyruvic acid, which is also a what a ketone. This is a ketone. Why do we call this a ketone? Because of this, right? So that's why we call it. This is what phenylketone. They call this guy what phenylketone. That is where we have the PKU gotten from. PKU, that is phenylketonuria. Okay, the appearance of your what phenylketone in your what in your urine. So thanks very much for watching this lecture. So make sure you subscribe to the channel, like the video, and comment. Thank you.